Hi everyone, today we're going to be looking at balancing redox reactions, specifically in an aqueous basic solution, as it involves an extra step than in an acidic solution. So this particular example is from one of your mock exams, so that could be useful for you in terms of verifying whether you got the correct answer, or if you're stuck, or if you just need some help in general with balancing redox reactions. So let's get started. Okay, so the first thing is that you're going to have to recall how to assign oxidation numbers from back in Chem 1. And if you don't, then you might want to review that prior to continuing. Also, it might be handy to memorize them or write them out on your flashcard. So when we're assigning oxidation numbers, I like to start with the first part of the reactant. So we're going to look at zinc here. And we can see that it's got a 0 oxidation number. And then when we go over to the product side where we see zinc again, we're going to actually have to look at the oxidation numbers for oxygen and hydrogen before we can determine what the oxidation number is for zinc. So we know that oxygen is generally -2. And in this case, we have 4 of them, so we're going to have -8. Hydrogen is generally +1, and in this case, we have 4, so we have +4. So we want to see what we're working with now in terms of our charge, and when we calculate these together, we get -4, and we know we're trying to get an overall charge of -2, so we just need to add 2. And that is going to be the oxidation number for zinc. We're going to go back over to the reactant side and look at manganese. Again, to determine manganese, we have to actually determine the oxidation number for oxygen. So beginning with -2, noticing that there's 4 of them, so -8. We have an overall charge of -1, so this is going to be +7 for manganese. Going over to the product side, again, determining oxygen at -2 for 2 of them, -4. There is 0 for its overall charge. So manganese is going to be +4. Okay, so that's the first step. Next, we want to see how are the electrons being transferred. So we're going to go back to zinc and see how that's changing from the reactant side to the product side. So we have 0. We're going to +2. So that means that we're going to be losing 2 electrons. And remember that when you're losing 2 electrons, the oxidation number is becoming more positive. We're going to then look at how manganese is changing. So we have a +7, and we're going down to a +4. So we're gaining 3 electrons. Okay, so now I've went ahead and summarized what we learned from the previous slide here, so we can use it to proceed. Also noting that manganese was reduced because it was gaining electrons, whereas zinc was losing electrons and therefore being oxidized. Okay, so we want to write their half reactions, and so we're actually going to take that information of being reduced or being oxidized to determine how to write our half reaction. So we'll see here in manganese, because it's being reduced, we see the electrons being added on the product side. So one can assume that for oxygen, the electrons are going to be added on the reactant side. And that's an important thing to remember, because that's going to aid you in calculating your overall reaction here. Okay, so the next thing to do is to notice that we never have these electron numbers in our overall reaction. So they must be canceled out, and that is exactly what happens. So we want to look at the lowest common denominator for both of them. So we know that would be 6. So we're going to actually multiply manganese here, or the reduction here by 2, and then the oxidation here by 3. That in turn will make them the following half reactions to look like so. And then we can cancel out our 6 electrons on, because one's on the product side, one's on the reactant side. And then we're just going to carry these down into what will make the overall reaction. Now, be very careful and meticulous here. I notice a lot of people make mistakes and they don't carry things down correctly or at all. So just make sure that you're accounting for everything. And then we're almost done. So now, remember that we actually have not balanced our oxygens or our hydrogens. And one thing to note is that when we were first presented with this reaction, we should have made sure that the zincs and the manganese were balanced prior to continuing. And I had already identified that, well, you know, we have a zinc here, manganese here, and a manganese here. So it's already balanced in terms of every element except for oxygen and hydrogen. But should there have been, you know, 2 zincs here, then we would have wanted to balance that out on this side as well. And same goes for manganese. Okay, so now we have to balance out those oxygens and hydrogens. And I find it the easiest to start with oxygen and then hydrogen. And that's because when we're balancing out oxygen, in order to add oxygen in, we are going to use H2O, or water, to do so. So we can determine on the product side that we have, 4 plus 12, so we have 16 oxygens on the product side, and then we have 8 oxygens on the reactant side. So we need to add 8 waters or 8 oxygens in order to balance it out. Now we want to balance out our hydrogens. And because we're starting with an acidic solution and then moving into a basic solution, we want to be adding hydrogen ions. So we have 16 hydrogen on our reactant side, and we currently have 12 on our product side. So that means we have to add 4 hydrogen ions to our product side. Okay, so this is where one would stop if they were working with an aqueous acidic solution. But now we want to get it into an aqueous basic solution. So to do so, we have to add OH minus. So when we're doing that, however many you add on this side, you want to add on the reactant side. And you want to add them for every hydrogen ion. So if we have 4 hydrogen ions, we'll be adding 4 OH minus. And then when we're adding, and then whatever we do to that side, we're going to do to the reactant side. So we'll be adding 4 over here as well. So this is getting canceled out here. And on the reactant side, the H2O is going to actually combine with the OH minus. And so you're going to see that we have 4 waters, and we have a remaining 4 OH minus that didn't get canceled, that was not canceled out from this product side. So this is our overall reaction. So I hope that clears things up, and best of luck on your exams.